Lesson 6.1, Trigonometry, Angles and their measure introduced. Yeah, whatever. So, trig's a study of relationships among angles and sides of right triangles. A lot of people aren't clear. Why is trig one of the most used types of mathematics in the world? Well, anything that rotates, forgot I got to write neat today, rotates or cycles will have trig involved in it. And when you think about it, everything is vibrating or rotating or cycling. Your heartbeat, the world around the sun, the world around its axis, the moon around the world. Any engine, motor is going to be cycling, rotating. And trig is also very useful as we're going to show, anything with a right triangle. So let's establish some ground rules, go from there. We're going to draw things in standard position. So draw a coordinate plane. It's really important to remember that we're working in a coordinate plane. A lot of people forget it and just assume we're just doing some random thing here. And this is our initial side. In this case, this is our vertex, the origin. So the vertex is at the origin. And when we draw it, we count 90 degrees, 180 degrees, and 225 is somewhere in there. We don't care if we're exact. Do have to put a little arrow, though. This indicates we started at the initial side, and we ended up at the terminal side. Notice that positive is in the counterclockwise direction. Negative would be in the clockwise direction. And just so we're all clear, we give the quadrants names in Roman numerals, but we just call them quadrants 1, 2, 3, and 4. Take a second and absorb all that. There is a lot cooking there. A lot cooking there. A lot of people think, oh yeah, it's not a big deal. It's a big deal. There's a lot going on. So you look at that and you say, great, so that's the only way I can get to 225. No, there's a lot of different ways. We call them coterminal angles. So I will draw one right in the middle here. And instead of going forward 225, we could have gone backwards 135. And instead of that, we could have gone around twice. So this is 360 plus another 225 is 585. You might say, like, well, they're all different. Yeah, they're labeled differently, but they're the same thing. It doesn't matter. You get there, you get there. It doesn't matter how you get there. All right, you could also have gone backwards with an extra loop, or you could have gone 2 loops. Start to get the idea. And I only bring this up because a lot of confusing math problems are written as negative 135, and you need to understand that's the same as 225. So this would be negative 495, I believe. Check my math. I'm not using my calculator until later. Well, speaking of which, I'm going to need to get that up and running. So this is some old-time math. This hasn't been done before in my classes, but it's important to be aware of it. Really only used by a fraction of the world, but when you see it, you need to know what you're talking about. These are degrees, minutes, and seconds, or DMS. And instead of saying 23.5 degrees, we would write that as 23 degrees and 30 minutes. You might be wondering what the hell just happened. There's 60 minutes in an hour. There's also 60 minutes in a degree. And 60 seconds still equals 1 minute. So how do I convert to DMS? Well, that's 23 plus, I go 0.15 times 6. I'm doing that on my calculator off to the side. 23 times 0.15, pardon me. I just go 0.15. We'll leave it at that for now. I get 9. So this becomes 23 degrees, 9 minutes. And if you're not sure that that's the case, check your work. 23 plus 9 over 60 is 23.15 degrees. All right? It's just a different way to draw it. It's like doing units. It takes a little getting used to. This one's a little trickier. We take 0.691, multiply by 60, get 41.46. We're going to ignore this for a second and say that we would have 153 degrees, 41 minutes. Well, what about the 0.46? We'll multiply that by 60 again, and that'll give us seconds. And it says 9.6 seconds. But you know what? I'm going to write it as 10 seconds. So when I check this one, I'm not going to get quite the same answer. Going forwards and backwards is pretty much just dividing or multiplying by 60 or 3600 in the case of seconds. I'm going to show you some cool stuff here so we can convert 1530. I forgot got to mess with my screen here to make sure it fits. Top's good. Bring this side over. It's not letting me. You know what? This will have to do. You can see it and you go from there. So I want to make 15 minutes and 30 seconds. So 15 second angle. There's my degree. 30 second angle. There's my minutes. Hit enter, it should give me 15.5. You can't quite see it. It's off screen to the right there. Apologies. So, what's 15 degrees in 30 minutes? 15.5 degrees. That's 15 plus 30 over 60. Here it's 50 plus 6 over 60 plus 21 over 3600. So again, I can use that whole degrees thing on the calculator, or I can just plug it in this way. 5.11, and we're rounding to 2 decimal places generally. I'm not actually happy about that, but that's just a decision that was made. So you might say, well, wait a minute. How do I get 6 minutes 21 seconds? 50 second angle degrees. 6, I hit the wrong button. Second angle degrees. 6 second angle minutes. And what was my last one? 21. 21. Where's the seconds? Alpha plus. What the heck's it doing there? Yeah, good question. No idea. And again, you can see it. 50.11, which is what I got over here. And I wrote it wrong. Details. Very upsetting. But I always teach my students never to trust me. So there you have it. All right. Yay. Degrees, minutes, seconds. Get that out of the way. What are radians? Well, radians are rough. We're going to use something called a unit circle to explain it. And really, there's no other way to explain it. Radians are just out there. And after you've worked with them often enough, you start to understand, all right, I see why you're using radians. Degrees, where there's 360 in a circle, better, is random. 360 comes from the ancient Babylonians who had a base 60 society. Radians is a made-up number that fits for any situation, any circumstance. Here's a unit circle, meaning that the radius is 1. One what? Just 1. What's the circumference? Hopefully you remember back to 7th or 8th grade. math, or if you just took geometry, circumference would be 2 pi times 1 would be 2 pi. And that's how we measure radians. This is 0 radians. Once around is 2 pi radians. Halfway is just pi radians. This is pi over 2 radians. And this is 3 pi over 2 radians. So, if you were to match that up with degrees, and they are the same type of measure, how far around the circle are we going? This would be 0 and 360 degrees. This would be 90 degrees. This would be 180 degrees. And this would be 270 degrees. Keep that in mind. We're going to come back to this and really hammer the heck out of it. So that's a circumference in radians. So this is the most important one out here, pi over 180, or pi in 180. All right. Oops. This is what we just said, radians. Pi over 180. So we can use that to convert from degrees to radians. You can actually work with your radians in your calculator. So right now you hit mode, and my calculator's in degrees. Second, quit. I say sine of 45, and it gives me 0.707. Mode. I'll show you why this is true in a moment. 45 degrees is pi over 4 radians. Sine of pi is under the caret. 4. I got the same thing, 0.707. So your calculator can work in both. And then the really weird part is that that's actually root 2 over 2. We'll come back to that soon enough. So how do we convert from radians to degrees? Well, if I have pi radians multiplied by 180 over pi, that's 180 degrees. If I have 270 degrees multiplied by pi over 180, do some math, and I get that's 3 pi over 2. Hey, I got that off the unit circle. That would have been easier to do it off the unit circle. I agree. Notice I wrote down degrees. I did not write down radians. Radians are magical. They vanish. You don't have to write them down. If it's not written down, it's assumed there's radians. Sometimes I write them in the middle of a problem I'm doing, especially if it's a word problem, because I don't want people to get confused. But generally they're not written. 3 pi over 2, by definition, means radians. It gets even worse than that. Sometimes you look at a problem and you say, there's no radians in there. I wonder if they're talking about radians. Yes. Pardon me, there's no pi in there. I wonder if they're talking about radians. Yes. I could multiply this out and say this is also equal to 4.71 radians. And you would say, well, do you want me to leave pi in it or not? And I would say, I could write out radians. Sometimes we leave pi in the answer, sometimes we don't. Read the question, look at the answers if you're doing an ACT, look at the instructions if you're doing one of my questions. I'll try and be as clear as possible. This causes headaches for people, but it's not that bad. Want to convert to degrees? Put degrees on top. Want to convert to radians? Put the radians on top. This is degrees on top. This is radians on top. Takes a little doing, but it's no big deal. So again, and I would pause the recording now. 23 to radians. Well, that's pi over 180. I believe they don't cancel at all, so I'm just going to leave this 23 pi over 180. Wait, that's lazy. You can't do that. Yeah, I can do whatever I want. This is America. Convert 4.7125 to degrees. Oh, well, degrees on top over pi. This one, why? I'm going to multiply out. I don't know. It looks like it might work out to something cool. Ooh, it does. Gives me almost exactly 270 degrees. Hey, wasn't that in the previous problem? Maybe. You'll have to scroll back up and look. Radians make it much easier to find an arc length. A lot of people like to work off of degrees, and I'll show you how that works. But I really, once you get to radians, it becomes a lot easier. So let's say we have a pizza with 8 slices. The arc length would be the, let's see if I can find my pen here. I'll do it this one. The length of a crust. And you say, I want to know how much crust, infinitely small crust, but how much crust is on 1/8 of a pizza? Well, most people would say, well, that's 45 degrees out of 360 degrees. And we're just going to go 2 pi. Let's make this a 10-inch pizza. So 2 pi times 10 inches. 45 out of 360. Sorry, I feel like writing things neater. Times 2 pi times 10. And off we go. Well, we got a neat little process we'll work with here. Let's go with 45 degrees. And let's go with 2 pi over 360 times 10 inches. And if you simplify this, you see it gets down to pi of 180. So this is the angle you're going to use, and it's already in radians. So rather than convert it, just work in radians in the first place. So you're going to get the radius 10 inches times theta. S equals R times theta. Arc length radius angle in radians. And to finish off up here, you get times pi over 4 equals 5 pi over 2 inches. Which you might point out, well, that doesn't really mean anything to me. And I said, yeah, you can always blast it out as a decimal. But for the time being, we're just going to leave it there and just say that's good enough for now. I feel like I did something wrong there. Nope, that's right. So here you go. Here's some practice. You can pause the recording and knock it out. Bothers me there's no units here, but oh well. And that's how quick it's done. Pi over 2. Whatever that unit is. Inches, meters, centimeters, some length. Now this is something like 2 pi, but okay, we're given a decimal. Let's give a decimal back. Doesn't really matter. It doesn't have to be in radians every time. It doesn't have to not be radians every time. But if they give us radians, we'll leave it in radians unless we have to find out otherwise. If you ever become an engineer or something, you're going to have to blast it out and see what number you get. All right, this is how long the hose is. That's going to wrap around a big circular, pipe or something like that. Again, no units given. So that's about it. I don't have my happy mathing sign up, so I'll just write it here. Happy mathing.